Hello everyone, my name is Saili Kadam. In our previous video, we discussed KNN algorithm. In this video, we will be talking about naive Bayes algorithm. So let us get started. So as in KNN algorithm, we used to first decide the value of K. That was nothing but the number of neighbors that we will be considering while coming up with a decision. In the same way, naive Bayes, the concept behind naive Bayes is Bayes theorem. So we use Bayes theorem to find out the probability that a new data point, there will be multiple classes. So to which data class the new data point will belong to. For that reason, we use Bayes theorem to find out the probability, and the class that has maximum probability, the new data point will belong to that class. This is a basic working. So the main concept behind KNN algorithm is the Bayes theorem. So this is the formula for Bayes theorem. We have already, everybody knows it. So here in Bayes theorem, probability of A by B, we call it as the posterior probability, and this is something that we are supposed to find out. The main aim of naive Bayes algorithm is to find the probability of A by B, which we call it as a posterior probability. Then we have B by A, that we call it as likelihood. Likelihood is the probability of a B event. So there are two different events. The probability of occurring of B when already one event is true, that is likelihood. Then the next term, that is probability of A, we call it as a prior probability. So prior probability is the uh, probability of event occurring of event A, that is basically probability of A. And then we have probability of B, which we call as the evidence. The formula remains exactly the same, only there are some new terms that we are going through here, like we have the posterior probability, the likelihood. So here we don't directly say probability of A by B or probability of A. Here we use this terms posterior probability. This is the aim, this is what we need to find. The likelihood is how often will B occur when A is already true. Then posterior probability is basically event A, what is the probability that event A will occur, and the evidence. So this is the only formula that we will be using in Bayes theorem. The Bayes theorem is again very simple algorithm, I would say. So let us consider an example and understand how Bayes theorem actually works. So let us say, uh, let us consider I have a data set. Let us say that this is study, that how long are you going to study, if you study or not. So this column will represent the study, and the second column will represent the result, whether you are pass or fail. Then if you study, let us say yes, you study, then you will pass. So this is basically data set. This is yes. Again, let us say you study. Again, you have pass. Here you don't study. Let us consider it no. Here you fail. This is, I'm simply taking it as an example. This is fail. Again, I have no. And again, it has fail. Then we have you study, and then you pass. So let us say we have this data set. We have this data set where if you pass, so clearly, we can clearly see that if you study, you pass. If you don't study, you fail. And now we have new student. So this is a data set for a student. A student studies. he or she passes. If the student don't study, he or she fails. So a new student enters and we are supposed to find out whether the student will pass or fail. This is our aim. So firstly, what we will be calculate? We know the formula now. So the very first thing that we will be doing here is, firstly we will calculate the prior probability, that is P. So it will be for, so there are two classes, either pass or fail. So for pass we have 3 by 5, 3 by 5, which is 0.6. 0.6. Then we have a different class, fail. So fail will have probability 2 by 5, which is 0.4. Right? Then now we are supposed to find out the likelihood. That means how many students actually studied and actually passed. So here, how many are there? 3 of them studied and 3 of them passed. So that becomes 3 by 3, which is equals to 1. So now our likelihood becomes 1. Then we will calculate the evidence. What will be evidence? Evidence will again be 3 by 5. Because, so 3 students studied and 3 of them passed. So again evidence will be the same. So evidence will again be 0.6. So then we will put that into formula and we will get the answer like 1 into 0.6 divided by 0.6, which will give us 1. That means 100% probability. Again, if we have another class, for that also the formula will remain same, only this value will be changing, that is 0.2. Here we will put 0.4, sorry, we will put 0.4 here. And then we will get some other answer. But here we have 1, so 1 will be obviously maximum. So we will consider this class only. That means the new student will pass because the probability of pass class is more than the fail class. So the new student will pass. If we are supposed to calculate, we will calculate this as well. So that will be 1 into 0.5, 0.4 divided by 0.6. This will be, this is how the new equation will be. So this will be something like 0.66 something. So this 1 is greater than 0.66. So the new student will pass. So here we have one very important concept, that this evidence always remains the same. For all the classes, the base will always remain the same. So for comparison, we don't consider this. We can ignore this part, this one. And directly we can go for only numerator part. We can simply multiply the numerator, that is 1 into 0.6 and 1 into 0.4. So this will be 0.6 and this will be 0.4. Then again this one is maximum, so that means the student will pass. This is what we will classify. This is how we will be classifying. So basically we use Bayes theorem in this way. Also, we need to remember that we can also ignore evidence while coming up with the result. This is the basic working of naive Bayes algorithm. So this is how naive Bayes works. So firstly we collect the data set, then we calculate its prior probabilities, likelihood, then we get, so here we have not considered evidence. Earlier we calculated evidence, but here we did not consider it because we can ignore it, because for every class it remains the same. So we calculate the likelihood, then we receive new data point, we apply the Bayes theorem. So basically we calculate this, then we calculate the probability of each class. Like in our example, the probability for each class was 0.6 and 0.4. Then we compare these probabilities. So we simply put the values in formula, we get new values and we simply compare them. And then we return the prediction. So the maximum probability, the class that has maximum probability, the new data point will belong to that class. This is the working of naive Bayes algorithm. Then, as KNN algorithm had its own assumptions, even naive Bayes algorithm has its own assumptions. So the very important assumption of naive Bayes algorithm is feature independence. Naive Bayes algorithm assumes that all the features in the dataset are independent of each other. This is a very important feature of naive Bayes algorithm. Then the second assumption is all the features, they contribute independently in making the prediction. And the third assumption is future data follows patterns similar to the training data. So whatever is in the training data, it assumes that all the patterns are already covered in the training data. The testing data won't have anything new. These are the assumptions of naive Bayes algorithm. But a very important assumption of naive Bayes algorithm is feature independence. It assumes that the features are independent. Then we have, this is basically the feature independence assumption that is not always possible in real world. The feature independent, mostly the like 90% of the times, whatever the data set is, there may be multiple features in that data set. So mostly 90% of the times they are dependent on each other. So in real world scenarios, this feature independence is rarely achieved, or feature independence rarely exists. But still this algorithm performs well. The predictions given by this algorithm are mostly accurate, or the working of this algorithm is well, it works so well. So there is a contradiction. It says that the features are independent of each other, but in real life scenarios, this rarely happens. But still, that don't affect the predictions, or the result are good enough of this algorithm. So we call this algorithm as naive. So Bayes comes from the Bayes theorem, and naive comes from this assumption that the features are independent, which is always not possible. But still that don't affect the results. That is why this algorithm is called as naive Bayes algorithm. Then again, this algorithm has some advantages, that it is very simple. There is only one thing, Bayes theorem. Directly we need to implement the formula. So it is very simple and easy to understand. Then the training and prediction, all of this takes place very quickly. So it is again fast. When we have small data set and when variations, or when we have limited number of categories. So now in our example we simply had pass or fail. A student can be either pass or fail. So in those cases we simply have two classes. We simply need to calculate the probabilities for two different classes and come up with the prediction. So for this, when we have very limited number of features, at that time this algorithm is, I would say, best. But if let us say we had 100 classes and then we need to classify them, that becomes difficult because we need to calculate the probability for each class then. So when we have small data set with limited number of features, naive Bayes algorithm is very good. Then it can handle multiple features, but that don't mean there should be 100 or 200 features. But multiple features, they can be handled. Then the important concept is, or the very important application of naive Bayes is in text classification. Like naive Bayes is widely used for text classification. And Yes, it also handles multiple features. These are the advantages of naive Bayes algorithm. Then it has some disadvantages also. As I mentioned earlier, the independence assumption, which is the most important assumption of naive Bayes algorithm, that the features are independent. But in real life scenarios, this condition is mostly it is never true. So this is a disadvantage of this algorithm, and there may be cases there the probability can be zero. So this is also a disadvantage of this algorithm, that if there is nothing, so as we discussed earlier, that it assumes that all the patterns are covered in the training data itself. So let us say that in training data set, there was a pattern, there was a pattern that was missing from the training data. But in testing data, it came, and at that time, that means the probability of that patterns becomes zero automatically, because in training data, it was not there. So that is why it will be a problem, because it will simply say that the probability is zero for this pattern. But in testing data, it may arise, and there we can get wrong predictions. When the problem becomes very complex, as I said, the size of data set increases or the number of feature increases, at that time the accuracy automatically gets lower. So these are some of the disadvantages. Then, as we said, that the disadvantage for zero probability is always there. So there we do something that is called as Laplace smoothing. So it is a technique in which we ourselves add one to prevent zero probabilities. So let us say in our data set, or in the example that we considered, there so it was study and pass or fail. So let us say a student studied but it failed. There was no such case, right? So for that reason, we will be having here zero. For that, the probability in our data set will be zero. So in our data set, let us say we had not studied and failed, but there was no data point that not studied but passed. So let us consider that example. So a student that did not study but still passed. So the number of observations were zero, and the total number of entries were 2 for not studied. So again, this probability will be zero. So we will be adding 1 to both numerator and the denominator. So it becomes 1 by 3, but the number of, so here we have number of observations as 2. We added 1 to this, it becomes 3. And also here we have added 1. So now the number of observations will become 4. And it will be 1 by 4. So we avoided, did you understand it? That in our data set, the students who did not study but still passed, we did not have any such case. So that becomes, the probability of it becomes zero, because there is no such entry. And we simply had two test cases where the student did not study. So we do divide by 2. To avoid zero probability, we add 1 to both numerator and denominator. So it becomes 1 upon 3. But now here we have 1 in the numerator. That means we are considered that there is one case where the student studied and did not pass. So that means this gets added to the denominator as well. So it becomes 1 upon 4. And then, so we basically avoided the zero probability to be 0. So the answer will be 0.25, which is not equal to 0. And this is the aim of Laplace smoothing, to avoid the zero probability problem. Then we have some of the applications of naive Bayes algorithm. It is so it is a classification algorithm. So we can use it in spam filtering. Like we have mails. We have been discussing the same example from very first session. So the spam can be either true, either mail can be spam or not spam. So only two categories. We simply need to find out the probability of each one of them and just come up. So let us say out of 160 of them were not spam and only 40 of them were spam. So the probability of not spam mails will be greater. So the new mail will not be spam. So basically the only thing that we need to do in naive Bayes algorithm is to directly apply Bayes theorem. And then it is also used in sentiment analysis, document categorization, and medical diagnosis. These are some of the examples or some of the applications where we use naive Bayes algorithm. That's all for this video. We will be covering other concepts that we use in machine learning in upcoming sessions, and we will be also discussing other ML algorithms. That's all for this video. Thank you.